Well, hi and welcome to my shop here. Today is January 14th and this will probably be a fairly quick video. I'm going to be investigating this power supply. So, like a lot of things these days, this power supply feeds something, a radio that somebody values. Actually, it's a Black&Decker shop type radio. And so the story from the owner is the original power supply. Oh boy. The original power supply failed. He managed to buy this one, I'm guessing over eBay, and when he got it, it didn't work. And he's noticed that the cabinet is cracked here, but what he may not have noticed is that it's also melted right in here. It also looks like it's melted in here. This is not a good sign. Doesn't mean it's ruined, but would suggest that something has happened that has caused a large load to be placed on this. So I think it's a simple matter of opening it up, looking inside, and then doing a few tests on it and see where it stands. In fact, you know what? Even this sticker on the front here is brown. Can you see that? It's not so apparent in the camera, but the lower part is a little brown. Again, another sign of overheating. The thing about this, the unusual thing about this, and this is pretty heavy so it has transformers in it, is it has two output voltages. It has one at 11.4 and another one at 21.3 volts. It's two power supplies in one, which is a little unusual. Even though it's got 18 volts, of course, this is the marketing voltage. This is what people they want, an 18 volt system. So you got an 11.4 and a 21.3. Hey, maybe that averages 18 volts. If you look inside the connector, which might be a little hard to see in the camera, let me just put a little more light on it here. There are 4 contact pins inside there. Typically you'd find 2. Or in a lot of cases you don't have this kind of connector at all. You've got that simple barrel shaped connector. That's not a very good example of it. And I don't think I've got one right away handy for this one. No. But I think everybody would know what I'm talking about because these kinds of things are everywhere. Here we are. Like a lot of these power supplies have this kind of connector in it. It's just two wires here and one voltage. So that's why it's so hard to get a replacement for this guy. I suspect, especially it says Black&Decker right on it, that these were manufactured specifically for that radio that he has and for nothing else. Yeah, this isn't even really a crack here. This is a shrink of the plastic in here. Isn't it coming up? Yeah, you can see it on the camera there. Well, let's pop it open and we'll find out what's inside. And I have the feeling this is going to have a bad ending to it. So I think it's sad how much devices there are that have these kinds of Wallwart power supplies. That's a nickname that's used, Wallwart. And these power supplies break down, usually because the cord breaks right here, or even more typically, right in this area. The cord breaks just from being overflexed. And then the owner is stuck, just like this. Now you can buy universal power supplies. They're everywhere. Adjustable output voltage and polarity can be switched. And they usually come with multiple connectors, but nothing like this. And this is a 2-in-1 power supply, so no, you're not going to find a universal 2-in-1 power supply. Not going to happen. Let's take this off. Here we are. Okay, so it's one large transformer. Little circuit board. There's looks like a fuse. Looks like 2 fuses soldered right onto it. Now, the only thing that could really heat up in here is this transformer. Doesn't mean it's gone defective. Not necessarily. So just looking it over for anything obvious. The two 120 volt plug terminals just rise up inside here and are just soldered to the two wires for the primary side of the transformer. The transformer itself doesn't look terrible. It's not blackened, or it doesn't look like it's fallen apart or anything. I suspect, my guess is there's a defect in the cord here or here. The defect has caused a short circuit, and the short circuit has caused the overheating. And with the short circuit there, it's not going to, no voltage is going to reach the end here. So we're going to check this stuff. I have a way of powering this and restricting the amount of power in it. Let's take a close look at those fuses first before we get too far into this, and only to have some bad fuses. Okay, I'll just bring this over. Now, is my camera going to focus? Okay, so I've got to. I'm going to take manual control of the focus on this camera. Just bear with me a moment here. I just have to call up the... Oh! Who's that? What's that? Okay. Just get really close. Not so close. So it looks like I can see the fuse element inside that fuse. I think I see it in this one too. So I think the fuses are good. Wow, you'd think if you put a short circuit on here sufficient to overheat this power supply, that the fuse would be designed to blow and protect everything. That's what you'd think. Oh my gosh, Peanut. Okay, I have to go play with my cat for a few minutes here. Make them all happy. Here I come, Peanut. So in my shop I have a couple of different ways to restrict power coming to something like this, just in case there's a defect like it appears to be with this guy. One way is to use this device, which is very handy. That's called a power right. And I can just turn this knob up and down and it changes the voltage that'll be supplied to whatever. I can measure current with that too, so I can see what kind of draw there is. Now, another way I have is called a dim bulb system. A little hard to see in my shop. It's kind of dark over there. But there's two bulbs up here, not this. That's a spare bulb. And if I throw my control panel switches right, the power reaching here, reaching this guy, is going through these light bulbs like they are big resistors. The beauty of this is if the load is way beyond what you would expect, these lights come on really bright. And that's right in my face and tells me something's going wrong. Other than that, it's a little bit clumsy, but I like using the dim bulb system. So I'm going to make it a little more sensitive by unscrewing one of the two lights. So it's all going to go through this low wattage bulb that you can't see in the dark there. My expectation is I should be able to turn something on like this and those lights would never ever show anything because there's such a small current being drawn by something like this, especially when it's not plugged into anything. Should not cause anything. So we're going to try that out and see what happens. Now I'm just going to plug it into this guy here. I'm not too sure about what to expect. Just move the camera up a little bit. You can see my fantastic control panel here. These two switches. This one turns things on. This one selects either power through the lights or power not through the lights. So throw this down. You watch those bulbs, and we'll know, or bulb. We'll know something right away. Here we go. Okay, well, nothing on the bulb. Now, does that prove that this is not overloaded or whatever? No, it doesn't. It doesn't prove anything. Not quite. So let's see if we can actually measure the power going into this. So we can simply do that by pushing the right button here. This is now a current meter. It's going to read how much current is going into this. I have a couple other ways to do it. Let's try it. Here we go. Through the light bulb still. Okay, this just barely came up. You can't even see it. Okay. This meter is just showing the voltage that's arriving here. There was a time where I didn't have this box here. This box is really cool. Everybody should have one of these in their home. You can go around and find out exactly how much power things are drawing in your house. But I just have it plugged into my shop, my bench extension cord, and so we're going to look at this now. Okay, make sure this is all ready here. We'll see what this says. Let me just prop this so I don't have my hands on it. Okay, here we go. Power on again. Okay, so this is, there we go. 110 volts here. Check for power. Okay, the amount of wattage is 0. So there's no way this thing is going to overheat as it stands. Now there's a chance this event that took place here that melted this is because something was done wrong with this cord, or there's a break in the cord and right at the moment it's not shorted. Maybe it will short. So we need to watch a couple things at once. Keep your eye on this guy, keep your eye on this. This might be easier to see. If I generate a short at some point, the cord actually feels very good. It feels very strong through here. It doesn't feel like it's... I don't want to bend it a ridiculous amount. Did I have my hands up in front of everything? And we'll try down here. Okay. I don't see anything happening at all. Well, the next question is there any voltage coming out of this? Okay, so let's just use a digital meter here to find that out. I'll just get it set up here. Okay, so where we're going to hook up the meter, just a few more observations. One is the circuit board contains nothing but 2 fuses. So this is not a DC power supply, it's an AC power supply. And on here it says output 11.4 volts, no comment, 60 hertz, right after it, 60 hertz. So this is, the rectification and turning it into a DC is going on inside the radio itself. So when I look at this, I see 4 wires heading out. And I see 4 connections across the top here. 1, 2, 3, 4. Now, 2 of these are going to be producing the 11 volts, and the other 2 are going to be producing the 21 volts. Which are which? You'd guess the fuse would be 1 fuse for each circuit. There's a little bit of writing on the board underneath there, but it's just instructions for the person putting the wires in. Just some colors and stuff like that. Red wire goes here, that kind of thing. So we could guess and just prod around, but I'd like to be a little more sure. It would look like the fuse runs between here and here, and also between here and here. So I'm thinking this is one output, this is another output voltage, and these are the 2 matching terminals. So this goes with this goes with this, and if we put the voltmeter on there, we should get a valid reading. That's my thinking. So that's what we're going to do. I'm going to change the voltmeter leads from the clip to our regular voltmeter leads here. So this is going to tell us what's up. We don't see any voltage. It's shot. Okay, so we're expecting as much as 21. I have to put this up on 200. AC, Jim, AC. 200 AC. AC, 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 AC. Okay, we're going to turn it on still with the dim bulb in the circuit because we don't know for sure what's happening. There we go. What did I say? I said between here and here. 1.8 volts. Go on the other side of the fuse. Same thing, 1.8 volts. Let me check this side. Do it right. 0. The fuse blown? Even though I saw the link, sometimes the fuse can be blown. No, not happening. Okay, so the possibilities here are I'm doing this wrong. Something more going on this little board. Transformer is shot. Let's just kind of do various combinations of these. I think this would be an output. We see nothing on the meter. Let me just turn this a little bit, make it a little easier to see. Try again. How do I know my meter is working? Because it's showing something. Here, 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 here. So you would think, I would think, it's not likely that both of these would be defective. It's basically two transformer secondaries working with one primary. The hint here is there's been a failure in the primary side, and that the primary coil, the primary winding is shot. That's what we might think. Let me turn this off. That's very bad news. So what we want to do is there's some tape here. I'm going to nip away that tape and look underneath. See what we can see. It's not plugged in. There's no voltage in it. I don't want to cut any wires in there. What I'm hoping to see is the little brown wires that are hooking up the prongs to the primary of the transformer. I want to get a look at them. Expect materials like this to suffer under high heat. Maybe that's what's happened here. The tape I'm cutting off is crispy. You know what? I don't think this is going to help too much. Looks like there might be a compound in here. So the hope would be that one of these connections has failed, one of these brown wire connections, and it can be repaired. There we go. Okay, a little more. A little more. Uh-oh. Uh-oh, what did I touch there? A piece of wire right here. Well, normally what happens is the wire that was used to wind this transformer is not the kind of wire you want to have come out and go right to these terminals, although in some cases that would be what was done. In this case, they joined these brown wires to the actual coil wire under this tape. And it could be a very, very fine wire. Let's just take a close look with the close-up camera on what we got here so far, so I don't make a mistake. Maybe I already have. That looks like quite a mess. So I think this part right here is one of the wires coming out of the transformer, and then it's soldered to one of these brown wires. And I think I see the other one right here too. Chances of those connections having failed are kind of small. I mean, this thing did overheat. The solder gets soft. Oops. Solder will get soft. But the chances of it actually failing there is quite small. Chances of it failing internally after overheating like that, very, very high. In fact, really, if you wanted to lay odds, that's where you'd lay them right now. There's a short circuit on the primary side of this transformer. Open circuit, not a short, an open. Could have been preceded by a short, which could have caused the overheating. There we are, we're getting this exposed now. There, it's coming loose, completely loose. Broken wire, right there. Right there. Now, did I do that? Did I do that? Well, obviously the thing to do is to resolder that wire on. So we just a much better view in the camera here. We'll just solder that wire there, and we'll test this guy again. See what happens. There's a piece here that's supposed to sort of strain relief these wires. That's what it looks like. I don't know what strain would come through. I don't know. So now, if my story about there's a short or something like that in here which caused the overheating, it's going to happen again. It takes time for something this big to actually heat up. The issue with power is temperatures. The equipment has current ratings on it, but those current ratings are almost always based on what the temperature is going to be for the item operating. Sometimes they give a rating and they'll state a certain ambient temperature, or they'll give you a temperature rise over ambient. So the issue is temperature. I would say that wire broke there. How am I going to get this twisted up without... I don't have to worry. I'm trying not to put my elbow in front of the other camera, but you're not looking through the other camera. You're looking through this one. Try to twist these around a bit. You don't really want to work them much. What do we got there? It looks very different in the camera. The angle I'm looking from is totally different. There. Come over. Somebody join up with somebody. Here we go. I want to make a bit of a mechanical connection here, even though I'm going to stick solder on it. So, now, if the overheating caused this to happen, but the fuses remain good, that suggests the heavy current was not going out of the transformer. That's a bit of a bad sign. That would further suggest a problem in the primary winding here. let's solder that guy up. Oops. Sorry for the bad camera work at times. I have a little tiny piece of solder that I'm finishing off. It looks like it's gone missing. Got to start with a new. Here, we'll use this over here. Certainly ain't good enough for a test. So what can happen now is this thing can overheat, but we should see that with the dim bulbs or the current drain or even the smoke. The smoke may clue us in. Something's going wrong. But with no real load on it, this shouldn't even warm up, really. Maybe a little wee bit over a long period of time. Okay, we're ready. Power's off. This fell out. Just don't want it moving around too much. Okay, once again, light bulbs, meter. Here we go. What does the light do? Nothing. Voltage is 111 again. Okay, so it's not drawing an excessive amount of current. Is there anything on the output? Is there anything on the output? Okay, looking again. Between here and here. Hello, come on. Show me something. Nothing. Okay, in between. And I got the wrong spot. Between here and here. No, that would be across the fuse. I'm sure it's between here and here. 1.5 volts. Flip this on to watts here. 0 watts. Current flow 0. Just kind of wiggling it to see if it'll suddenly go. Ooh, that scared me. See, nothing happening. Current flow over here is nothing. Not so good. Let's just test my voltmeter here. I'm going to put it right on the 120 volts that are here. And make sure the voltmeter tells us that. There we are, 120 volts. What's this thing say? Well, that's a little odd. This guy thinks it's 111. Right on the terminals. My other meter says it's what? What's going on there? It's kind of weird. Going up and down. I'm just making a bad connection. Yeah, 120. This guy says he thinks it's 120 also. This is low volt. So I have another meter here, this one. So this is a poorly calibrated meter, but that would suggest 120. So definitely supplying voltage to it. Well, let's go even further with this. We'll we can go a little further. Okay, we'll go right on these connections I was soldering. There we are, 120 volts there. There's a remote possibility that my solder job didn't work, but that's really remote. Possible the other connection is broken and I haven't noticed. Let's turn the power off before I take an unnecessary trip. So, take a look. I have another closer up camera I'm going to get going here. We'll take a really close look. This is a little hard to relate to. If I move the camera around a bit, it should help. So you can see my solder job there. Can't imagine that's not making a connection. You can see the wire disappearing down into the transformer. The other wire. What's going on with the other wire? So much blue junk there. Let's see if I can pick it away. Well, it looks like I see it with my eye here. This would be the connection right here. And I can see the wire disappearing. It's a little hard on the camera, but I can see the wire going in there. Because this is almost certainly shot, I'm a little more aggressive with moving these things around. So it does look like there's a plate here, like a piece of plastic or something like that. They've stuck these two brown wires to. That looks melted. Let's just hang on here. It appears to be melted, or is that glue? That could be glue. That brown puddly looking stuff. Could easily just be a glue. That's what it looks like. Well, there's only one more test we can do here with this. Realistically, is ohm out the winding. Read the winding resistance, primary winding resistance. It should probably be, I don't know what it would be. It won't be 0 and it won't be infinity. So we're going to go on here and here. And what my meter is indicating is it's open circuit. That's a 200 megohm scale. That would be open circuit. Now let's just check the meter, make sure I'm not fooled. That's what a 0 looks like on that scale. Open circuit. Okay, let me beat this one to death. The primary winding in the transformer is open. Probably opened due to a short being applied to it. Where the short came from, we don't know. The short could even be internal inside here. It could have started in here with a breakdown of the insulation of the winding. Once that shorts out, this thing starts drawing a lot of power. Fuses are on the secondary side, so that they don't even know what's happening. It probably won't draw enough power to pop the fuse in your house or the circuit breaker in your house, and the result is this becomes a heater. And it heats up. This is the part that's a little hard to buy. It heats up to the point where a wire breaks inside. That's just the part that's just a little tough to buy into. But that's what it appears. a failure of the primary side of the transformer. So not coming back from that. It's finished. So thanks a lot for watching. Too bad it's ending this way. Perhaps the owner still has his original power supply, and perhaps there's some way to salvage that. If this were a single voltage power supply, it would be fairly easy to replace it, but it's not. So that's where it's going to end. Thanks a lot for watching.